Hello, today we're going to talk about specific heat. So let's go to the notes. You have the notes on Canvas, and you can follow along with me now. So specific heat is also sometimes called specific heat capacity. And that's the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree. Okay, 1 gram of a substance by 1 degree. And the heat is normally measured in calories or joules. And there's an equation which relates specific heat, how much heat it takes, again, to raise 1 gram of the substance by 1 degree, so we can compare the specific heat of different substances. We can calculate how much heat it takes to raise the amount of a certain substance by a certain temperature, and so on. So this is our equation here. Q equals specific heat times mass times change in temperature. In some books, specific heat is given just SH. Some books, it is given the symbol C. Let me grab my marker. Sorry. And some books, it is referred to as S. But all of those are the same thing. Okay, so specific heat. Q, again, is heat, calories or joules. Specific heat, SH or C or S. And mass has to be in grams, and the change in temperature, it really doesn't matter if it's Celsius or Kelvin, because they are, it's a change in temperature. Okay, so one or the other. Okay, so Q equals specific heat times mass times change in temperature. That's the equation we're going to be using. And specific heat has 3 different units because of it has to match the other units in the equation. So if heat is in joules, specific heat has to be in joules. If heat is in calories, then specific heat has to be in calories. Mass is always in grams. And like I said, temperature really doesn't matter if it's degrees Celsius or Kelvin. Okay, so example problem. Oops, not yet. Let's do this first. Wow, my it's getting ahead of me. There we go. All right. Water has a high specific heat compared to other substances. 1 gram of water requires 1 calorie to increase its temperature by 1 degree. And remember, a calorie is 4.184 joules. So 1 gram of water also requires 4.184 joules to increase its temperature by 1 degree Celsius. Okay, so that is something that you should know, that water specific heat is 1 calorie or 4.184 joules, because a calorie is 4.184 joules. Metals, on the other hand, have a much lower specific heat than water. So metals will heat up much faster than water. If you think about it, if you've gone outside on a sunny day and it had rained, and so there's mud puddles, if you touch the water in a mud puddle versus walking over to a car that's made out of metal, the car will feel much hotter. It will be much hotter because it heated up faster than that water. So specific heat is a property of a substance, how much heat it takes to heat 1 gram of it 1 degree. Water compared to other substances has a much higher specific heat. So also, if you've ever had, if you have a pool, or if you've gone to a lake or the ocean, and let's say it was pretty early in the season, maybe May, and sometimes in May, the air temperature can get really hot, might be 80 degrees air temperature. And you're like, oh, I'm so hot, I want to go swimming. But you run to the water and jump in, and guess what? The water is still really, really cold, because even though the air temperature is 80 degrees, it takes a long time for the water to get heated up that much. So that's why, it's because it has a high specific heat. Okay. If we add the same amount of heat to 1 gram of copper versus 1 gram of water, there's about a 10-degree difference. Okay, so adding the same amount of heat will raise the temperature of 1 gram of copper by 10 degrees. it will only raise the temperature of water by 1 degree. Metals heat up much faster than water. All right, so here's a typical problem with this equation. The temperature of a piece of copper with a mass of 95.4 grams changes from 25 degrees to 48 degrees Celsius when the metal absorbs 849 joules of heat. What is the specific heat of copper? So our change in temperature, make sure you always do final minus initial. Okay, that's important. Final minus initial. You cannot have a negative specific heat, and if you don't do final minus initial, you'll get the wrong sign on the heat, or you'll get a negative specific heat or negative mass or something that you're solving for. So make sure you always do final minus initial when you do change in temperature. So in this one, when it says it's going from 25 to 48, 48 degrees is the final temperature. 25 degrees was the initial temperature. Okay, so it has to be put that way, not 25 minus 48. Final minus initial. What else were we told? We were told how much heat was absorbed. That is Q. Okay, so Q is 849, and it said it was absorbed, which means it's a positive. Okay, if it's absorbed, delta H or Q is positive. If it's given off, then it's negative. So it's a positive 849 for Q. Specific heat is what we don't know. That's our variable. The mass is 95.4 grams, and then our change in temperature, 48 minus 25. So when we multiply, let's see, so 48 minus 25 is 23 degrees. Okay, so we have a change in 23 degrees. And so if we multiply 23 times 95.4 and we divide that over to the other side, so 849 divided by 2194, we come out with 849 divided by 2194. We come up with 0.387 rounded. Okay, and that the units on that will be joules per gram degree Celsius, because we have joules from the heat, we have grams from the mass, and the temperature change was in degrees Celsius. So joules divided by grams times Celsius. That is the specific heat of that copper. Okay. So if the same amount of heat is applied to 5 gram samples of copper and silver, which one will reach a higher temperature? So when we look at the specific heat values, copper takes 0.0920 calories per gram degree Celsius. Silver takes 0.0562 calories to heat up 1 gram, 1 degree Celsius. So copper takes more heat to heat up every degree than silver. Okay, so which one will reach a higher temperature? The one with the lower specific heat. It takes less heat to heat it up. So a lower specific heat will heat up faster, and adding the same amount of heat, it will reach a higher temperature. Okay, so the answer is silver. Silver, lower specific heat, takes less temperature to heat it up, so it will reach a higher temperature and it will heat up faster. Okay, another problem. What is the amount of heat required to heat 50 grams of water from 30 degrees Celsius to 65 degrees Celsius? The specific heat of water is 1 calorie per gram degree Celsius. So we have that same equation, Q equals, I'm going to use C for specific heat, times the mass times the change in temperature. Okay, so this time it's asking us for the amount of heat. That's Q. Okay, Okay, so we plug in our specific heat, which in this case is going to be in calories. We plug in our mass, which is 50 grams, and our change in temperature, final minus initial. So it's at 265, so that's the final minus the initial at. So it's a temperature change of 35 degrees. And we're going to multiply that 35 times 50 times 1 is 1,750, and that'll be calories because this was degrees Celsius. So grams cancels, degrees Celsius cancels, and our answer is in calories because our specific heat was in calories. And then that says convert that amount of heat into joules. So remember from earlier that 1 calorie is 4.184 joules. So when we multiply, got a couple of little extra dots there, times 4.184, we end up with 7,322 joules. So this is the harder type of problem, but you can do it. It's just doing the Q equation twice, okay? Because this is, if we would put a piece of hot metal into water, for instance, and measure the temperature change of the water, we could use that to find the specific heat of the metal. This is a lab that we usually do, where we will take a hot piece of metal, a chunk of metal, and we will heat it up. And then we will take that and we'll have a styrofoam cup because styrofoam's a good insulator. We'll have water in that cup. We will measure the temperature of that water before we put anything in there. And then we will put that metal in here and measure how much it changes the temperature. Okay, that's exactly what we would do in lab. We can do this in lab. And this would be the calculations. So the whole idea is that the heat lost by the metal, that hot metal, is gained by the water. We will know the mass of the water. We will know the specific heat of water. We will measure the temperature change of water. We will know the temperature change of the metal. We will know the mass of the metal. And so the specific heat of the metal is what we're solving for. So it's two Q equations set equal to each other because the metal transfers its heat to the water. However much heat the metal loses is gained by the water. So Q equals Q. So on this side, I'm going to put the metal information. And since the metal's losing heat, there's a negative sign there. Okay, so how much did the metal weigh? 25.64 grams. Okay, what I don't know is the specific heat of the metal. That's my variable. Again, I'm going to call that C. This is for the metal. And what's the temperature change of the metal? So the metal started at 100, and it's going to come to the same temperature as the water. Their final temperature is the same. Okay, so that's important. So the final temp of metal will equal the final temp of the water. So the metal's changing from 100 to 28.49 degrees. So that's the final temperature minus the initial temperature was 100 degrees. Okay, so that's the change in temperature of the metal. That's equal to the mass of the water, which is 50 grams, times the specific heat of water, which we're going to, it doesn't say if it needs to be in calories or joules. I'm going to do it in calories and then I'll convert it to joules. So that's 1 calorie per gram degree Celsius. And then the change in temperature of the water is 28.49 minus 25.10. Okay, so that's the change in temperature of the water, final minus initial. So calculating that, I'm going to simplify it a little bit. I'm going to subtract my temperatures here. So 28.49 minus 100 is negative 71.51 is my temperature change times C times 25.64, and all that has a negative sign, equals, and over here, my temperature change of my water is 28.49 minus 25.10. That temperature change is 3.39. So I can then multiply 50 times 1 times 3.39. That equals 169.5 on that side. And over here, I have 25.64 times negative 71.51. And then there's a negative sign here too. So that will be a positive 1833.5 C. Okay, so the negative sign of the metal on the outside cancels out the negative sign of the temperature change, so that ends up with a positive number. So now dividing over the 1833.5, I'll get 169.5 divided by 1833.5 equals 0.0924. And that will be calories per gram degree Celsius. Okay, that will be my specific heat of my metal in calories. If I needed it to be in joules, then I could just do that conversion, 0.0924 calories per gram degree Celsius. 1 calorie is 4.184 joules. So multiplying that times 4.184, I would have it in 0.387 joules per gram degree Celsius if I needed my answer in joules. Okay, so again, this is a little bit tougher problem, but it's just setting the heat lost by the one substance equal to the heat loss gained by the other substance. So it's the Q equation twice. Q equals mass times specific heat times change in temperature. Okay, so you're setting minus Q of the metal equal to Q of the water. Plugging in mass, specific heat, and change in temperature for both of those to get your answer. And you cannot end up with a negative specific heat for a substance. So that's why you have to pay attention to the sign of your change in temperature. And then the one that's losing heat, the metal, overall has a negative sign. Okay, so that's as far as we're going to go today with specific heat.